In this video, I'm covering section 7.3, which is on the law of cosines. The law of cosines says for any triangle ABC, little a squared is equal to little b squared plus little c squared minus 2bc cosine of big A. Little b squared is equal to little a squared plus little c squared minus 2ac cosine of big B. And little c squared is equal to little a squared plus little b squared minus 2ab cosine of big C. Now, all three of these formulas, which this is kind of in a bad spot, so I'm going to scoot it over just a hair. Oh my. Let me try again. Okie dokie. And I just want to scoot this stuff over a little bit. Okay, so all of these formulas can be solved for cosine of big A, let's say, and he is equal to little b squared plus little c squared minus little a squared all over 2bc. It can be helpful to have all three of these formulas solved for cosine of the angle. My arrows are a little ugly. Let me try those again. Okay. Cosine of big B. Again, to get to these formulas, just algebraic manipulation of the other side. But cosine of big B is equal to little a squared plus little b, oh no, not plus little b squared plus little c squared minus little b squared all over 2ac, and cosine of big C, because it's getting a little squishy, is little a squared plus little b squared minus little c squared all over 2ab. Okay, so for example, again, just a reminder, SOHCAHTOA is only for right triangles. So is a squared plus b squared equals c squared. Only holds true in a right triangle. When we're not dealing with right triangles, it's the reason for having the law of sines and the law of cosines, because they extend beyond those. Okay, so example number 1. We want to find all the missing parts of triangle ABC. Find all the missing parts of triangle ABC. Okay, and example number 1 is big A is equal to 16 degrees 21 minutes. Little b is equal to 26.5 meters. And little c is equal to 40.6 meters. Okay, so you don't have to draw these in order to do the problems. I do like to draw them, makes me feel better. Now A is supposed to be 16 degrees, 21 minutes, probably going to be the smallest angle My smallest angle to me looks like this guy, so we'll call him A, 16 degrees, 21 minutes. Doesn't matter who we call big B and big C, but once we've labeled big B and big C, we've automatically labeled little b to be 26.5 meters and little c to be 40.6 meters. And so who are we looking for this time? We're looking for big B, big C, and little a. Now, what tells us in this triangle problem that we need to use the law of sines and we can't actually use the law, we need to use the law of cosines. We can't actually use the law of sines. In order to use the law of sines, you need to be given an angle and the side opposite that angle. Since we're only given one angle here, we don't have enough information to find big B or big C right now. And when we are given side angle side, when we are given side angle side, that is what's going to tell us to use the law of cosines. I am going to write that in a little summary at the end. So based on what we know, the only thing that we can find here is little a, because little a squared is equal to little b squared plus little c squared minus 2bc cosine of big A, and we know big A, little b, little c, that allows us to find little a. Okay, so little a squared is equal to 26.5 squared plus 40.6 squared minus 2 times 26.5 times 40.6 times cosine of 16 degrees, 21 minutes. And I will be looking for an exact answer and an approximation on your test. So 26.5 squared plus 40.6 squared, according to my calculator, is our little a squared is 2350.61 minus 2 times 26.5 times 40.6, 2 times 26.5 times 40.6, again, according to my calculator, is 2151.8, 2151.8. That has a cosine of 16 degrees, 21 minutes attached to it. Now, this is actually as simplified as I can get right now, because cosine of 16 degrees, 21 minutes is some yucky decimal number. Order of operation says that we need to multiply here before we subtract, so you cannot subtract those front numbers even if you're tempted to. And it's at this point that we can say that our A is exactly equal to the square root of all of this, 2350.61 minus 2151.8 cosine of 16 degrees, 21 minutes. And then we will put that whole thing in our calculator, and because I gave you the sides to the nearest tenth, I'll ask you to round to the nearest tenth. Type that whole thing in your calculator, give me one decimal approximation at the end. If you rounded it correctly, I will know. So 2350.61 minus 2151.8 cosine of 16 degrees, 21 minutes, and hit equals, and it tells me that my little a is approximately 16.9 And my units are meters. 16.9 meters. Make sure that you don't forget your units and lose a silly point. And this is my little a.